So we're looking at a photo here of the MITS 88 SIOB serial TTL card with the conversion card we added on to convert it to the EIA signals for RS-232. So I can talk to standard RS-232 equipment. I've actually got a serial terminal we've looked at in previous videos that I intend to use with this at some point. So let's talk through in a little more detail here how the card's set up. So we're tapping off plus 16 volts right down here off the bus, the brown wire to the 7812 regulator. The plus 12 out comes over here to pin 14 on the 1488 driver. We're picking up ground from pin 7, so there's a pin header here that's plugged down into the socket that the 74LS367 or 1897, one of these chips, was in. So we're picking up ground from it to the ground pin on the 1489, to the ground pin on the 1488, and to the ground pin on the regulator. We're tapping off minus 12 up here off the board, follows the red wire down to pin 1 on the driver here. And then finally plus 5 is picked up from the pin header, pin 14 over here. Actually, I think that's pin 16 actually. Pin 16 to pin 14 here on the 1489. So we've got our power supply all set up. On the pin header, there was the TTL output from the UART over here and the TTL input for the serial data out and in. I don't remember which pins it was here. And then there was two other pins that came up to the TSN and the TS out pins here. You can kind of see the silk screen back there. And so one of the wires brings in the TTL signal and sends out the RS-232, and the other one brings other direction. You know, it's TTL to TTL to RS-232 and RS-232 to TTL. And I honestly don't even remember which one of these chips does what. But that's basically the wiring. A couple pins down here off to the processor, a couple other pins up to the pin header here. So really, that's the board is wired. We're still at address A7 0 and A1 to A6 is 1, so it's going to be port 126 and 127. Because A0 isn't included here, there's two ports, a control port and a data port. We've looked at the rest of the card in previous videos, so let's go ahead and fire up the MSI. Get it booted into CPM. So the power's on. I'm going to bring the camera over here as we always do so you can kind of see the front panel on the machine. I'll reset the machine. Power up floppy drives. CPM floppy's loaded. Examine address FF00 and run. And we should be booted. And of course I forgot to fire up TerraTerm over here. I should just make the font the large size we've been using, 28. It's actually a little bit big. It's not too bad. We'll get it up here where we can see it. So we booted into CPM. Let's go ahead and load up MBasic. The other thing I forgot to mention, if I can get this to move, is the data out is just jumping through a black jumper link here to data. Actually, data out here is jumping around to data in. And that way, anything we write out the UART should just come directly back around to the UART. And at RS-232 levels through the black jumper link. So let's go ahead and load SIOB.basic. Load list, and as the comments say, port 126 decimal status, 127's data. We're going to generate characters from 0 to 125. We're going to output port 127, which is data, the value of D. We're going to read it back in from port 127, so this should write to the UART, and this should read back what the UART's received. And we're going to print out as a hex string and character the data we expected as a hex string and character what we read back. If it sees an error, it'll stop and just say, hey, there was an error, and this should just loop here forever. So if we've got the wiring right and everything hooked up, this should just go into a loop. And beautiful, it does. So I'll stop this here for a second. So we're outputting hex 57, which is a capital W, and we read back a hex 57, which is a capital W. That's a really good sign. We'll let this loop here, and we'll bring the camera back over here. And I'm going to unhook one of these jumper links, and we should see an error and fail, and we did. So we definitely know that the data is being passed through the RS-232 converters, and at that point, that looks good. So again, planning ahead, giving it some thought, has paid off. This actually worked first try, which is really nice. It was bound to happen sooner or later. So not sure what else I can demo here. That's really pretty slick. Pretty happy with that. So this will be a short video. I'll see you in the next one.